So to this point, we have one solving technique that we've established, that's factoring. The catch here, though, is, what's the problem with solving by factoring? Factoring doesn't always work, right? I can't factor every polynomial. If I can't factor it, then I'm not going to be able to solve it by factoring. So that's a potential pitfall. Now, we didn't see any problems on our last assignment that weren't factorable, but we know the assignment before that we saw several polynomials that weren't factorable. So we need to come up with some other methods that we can use to supplement this solving by factoring technique. The first one of those methods is going to be solving directly. So let's say we have something like 4x squared minus 5 is equal to 0. So this is a quadratic. How can I tell this is a quadratic equation? Because it's an x squared in it, right? That's what we mean by a quadratic equation. It's just something with an x squared in it. Notice, though, this quadratic equation looks a little bit different than the things I've been dealing with. What's special about this equation? Well, we have no regular x's. All we have are x squareds, right? So in this situation, we can use direct methods to solve. So when I say solving directly, if you remember the order of operations that you learned in Algebra 1, when we simplify, we work from left to right. When we solve, we're going to undo from right to left. So if I return to this problem of 4x squared minus 5 equals 0, the first thing I would want to do is to deal with undoing any addition or subtraction. Well, I see that this problem has a minus 5. To undo that minus 5, I just need to add 5 to both sides. Now there's no more addition or subtraction going on. So the next thing I want to do is worry about the multiplication or division. I see that I have x squared times 4. So to undo the times 4, I'll just divide both sides by 4. To give me x squared equals 5/4. Now there's no more multiplication or division going on connected to the x. The next thing I want to deal with are the exponents. How am I going to get rid of that squared that's attached to the x? Yeah, we square root both sides. What do I have to remember when I square root both sides of an equation? It generates a plus or minus. So that's a place where I would say probably more than half of students forget this on a consistent basis. So I'm going to stop and say this again. Whenever you square root both sides of an equation, you generate a plus or minus. So whenever we're doing solving and you square root both sides, we get a plus or minus. So please, please, please don't forget that. Now, to square root a fraction, I can just square root the top and square root the bottom. Well, I can't do anything with the square root of 5 because 5 isn't a perfect square. However, when I square root 4, I can do something with that because the square root of 4 is just 2. And this is a fine representation for my final answer. Check. Well, we're not square rooting the negative number. What I'm saying is if I take this, like negative square root 5 over 2, and I plug it back into x squared, I get 5 over 4, which is true. Because when the negative times a negative gives me the positive back. Does that make sense? So that's why we're getting the plus or minus. So it's not inside the square root that the plus or minus is. The negative sign is outside of the square root, in front of it. Right? Like negative square root 2 is no problem. Square root negative 2, big problem. We'll deal with that big problem later. Maybe next week, probably. Probably not next time. Okay. Good question. So, everybody feel okay with that idea? So it's just basic, the reverse order of operations kind of solving. Nothing sneaky going on there. What if, though, instead I had something that looked like say that. Can I use a direct solving method on this? If I look at this left-hand side, do you see more than one kind of x? No, I just see one kind of x, right? I don't have both x's and x squareds. So I should be able to use direct solving on this. Okay. So what should I do as my first step? Definitely not distribute. Remember, we're not trying to simplify, we're trying to solve. We want to add the 8 to both sides. Again, we're going reverse order of operations, so we're undoing things. Just like in the previous problem, what should I do next? Yeah, divide 3 to both sides. Everybody agree with that? So it's just like the previous problem. It's tempting to want to screw around with that parenthesis, but we definitely don't want to do that. That's not getting us any closer to solving. Now what should I do? So I have to undo the exponent. Good. So how am I going to get rid of that squared there? Just square root both sides. Yeah. So even though that squared was around that parenthesis, it's still just around kind of one thing. So when I square root both sides, what do I have to remember? Plus or minus. And then my last step should be to subtract 7. Now, can I subtract 7 from square root 8? No. So how am I going to write this? I'm just going to write it as negative 7 plus or minus the square root of 8. Now, this is not the best version of this answer. If I look at the square root of 8, that can be simplified a little bit more. If I remember, 8 is the same thing as 2 times 4. So the square root of 8 is the same as the square root of 2 times the square root of 4. And what's the square root of 4? Just 2. So a better way I could write this would be negative 7 plus or minus 2 times the square root of 2. Now going from here to here on a test or whatever would be extra credit. I wouldn't expect you to be proficient at simplifying radicals yet. In fact, we'll spend an entire chapter talking about radical functions in the second semester, probably, and get a lot of practice at doing this kind of a skill. But I think that some of us have already seen this, and probably you did a little tiny bit of this in trigonometry last year when you did the sine, cosine, tangent stuff, where you had to deal with simplifying radicals in small doses. So I think that we've probably seen it a little bit, but it's not an expectation that you're able to do it. This is still full credit. This one is the extra credit, if you're able to do that extra simplifying step correctly. Okay? So, this was an important example, though. This has a big, big outcome. So, I know that I can take any standard form polynomial and put it into vertex form. Something that'll look like this. What process allowed me to do this? Does anybody remember the name of that process? We've talked about it here in the last week or two. We did a whole homework assignment based on it. So you guys remember this picture, right? So to go from intercept form back to standard form, we said we FOIL. To go from standard form to intercept form, we factor. To go from vertex form, we expanded. What did we use to go from standard form to vertex form? What was the name of that process? What was that, Sophia? That's the correct answer. That stands for completing the square. Now, what do you guys remember about that process? It wasn't a lot of fun, right? It was a pain. So, I don't really want us to have to do a completing the square process to go from a situation like this to a situation like this where we can solve directly. I'd like really just to have to do that once in a very general setting to create a formula so I can shortcut around having to do a completing the square anytime I need to do it. How does that sound? Probably a lot better than having to do completing the square over and over and over again, right? That should save us a bunch of time. So that's what I'm going to do next, is I'm going to, let me kind of outline what we're going to do. So this is kind of our plan. We're going to take some generic standard form polynomial. We're going to do completing the square so that we can write it in this form. So we can direct solve it. And the result is going to be a formula that we can use to get around having to do that completing the square and direct solving process every single time. We'll kind of have an answer already preloaded. Now the process I'm about to describe in detail here, I would not expect you to be able to reproduce. So you're welcome to take notes on it if you like. If you want to just kind of watch and listen, that's fine too. So what I'm going to describe here that I've planned out, or what I'm going to do in detail that I've just described, I guess I should say, is not something that's an expectation that you're able to reproduce. Okay? It gets a little bit symbol-y that is beyond the scope of what I think you need. The result is the part that we care about, and that's the part that I would expect that you know and you can use. But the how to get to the result, I don't expect you to be able to do again. Okay? All right. So we're going to start with our generic standard form polynomial. I call it generic because we don't know anything about the values of a, b, and c, right? They're just any kind of coefficient there. So the first step in the completing the square process is to make the leading coefficient 1. Right now, my leading coefficient is a. To make the leading coefficient 1, I can just divide both sides by a. Because division is distributive, dividing both sides by a is the same as dividing each term by a. So that's going to give me this. The next thing that I'm going to want to do is move the constant term to the other side. So I'll just subtract c over a from both sides. And now I'm going to use the completing the square process. So I'm going to take this middle coefficient, divide it by 2, square it, and then add it to both sides. Hopefully this process at least looks vaguely familiar. Again, I would not expect that you're able to do completing the square in a problem like this where you have all all like letter coefficients rather than merit coefficients. I would expect you to still be able to do completing the square if the a, b, and c were specific numbers like 4, 5, 6 or something. Okay. So the deal here was, for completing the square, is this piece now factors, and it factors in a very specific way. It factors into something plus something squared. The first something comes from the x squared. The second something comes from the last term. And then I'm going to just worry about trying to combine like terms on the right-hand side. To combine like terms, I'm going to have to simplify b over 2a squared. To square a fraction, I just square the top. So b squared is just b squared. And then I square the bottom. 2a squared is 2a times 2a, which is 4a squared. And now to combine my like terms here, I need to have a common denominator. So the common denominator between 4a squared and a is just going to be 4a squared. So I just need to multiply that fraction by 4a over 4a. When I do that, I'm going to get b squared minus 4ac all over 4a squared. Now I can start solving. So I've already got the squared part by itself. So all I need to do is square root both sides here. When I square root both sides of an equation, what do I have to remember? Yeah, say it again, everybody. That was 2 people. The same 2 people that said it the first time. One more time. When I square root both sides of an equation, we get a. I know it sounds stupid to ask you to repeat it, but like, I know from experience how easy it is to forget, and that's why I'm doing this, is just to make you say it. If you say it, it'll help you remember, I promise. Okay. To square root a fraction, I'm going to square root the top and square root the bottom separately. The b squared minus, or the square root of b squared minus 4ac, I can't do anything to simplify because of the subtraction symbol there. Square roots don't distribute, so I can't really do anything with that because there's that subtraction symbol there. However, the square root of 4a squared, I can do something with. The square root of 4 is 2, and the square root of a squared is just a. So my final step, getting the x by itself, is I'm just going to subtract the b over 2a from both sides. Notice here that we have a common denominator already, 2a. So I can just combine these together and write it as one big fraction. So I have then that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Who recognized this formula? About half of you. What's the name of this formula called? This is called the quadratic formula. So, would I expect that you have the quadratic formula memorized? Yeah. Yes. That part I would expect you to be able to reproduce and to be memorized, and to be able to use this formula. I would expect that. Would I expect that you're able to get the formula from, like, ax squared plus bx plus c equal to 0? No way, Jose. So I just want us to know the result of that solving process and to be able to use the result. I don't need you to be able to reproduce it, but I think it's important that you see where this formula comes from, right? That's nice. Okay, so what this says is that for any polynomial, ax squared plus bx plus c equal to 0, the solution is x equals negative b plus or minus square root b squared minus 4ac all over 2a. The thing we have to remember is in order to use that formula, it has to look like this. So you still have to make sure it's equal to 0. So everything still has to go onto one side, has to be all multiplied out. So let's do some examples of using this formula now. Yes, Tommy? Of course. Oh, don't do that. Okay. So, first thing, let's make sure that we are good at identifying the values for A, B, and C. What's the value for A in this problem? 1. Good. Right? The A is the one out here that we don't ever have to write. What's the value for B? Negative 8. And the value for C is 16. Everybody happy with that? Okay. So when I plug these into my formula, I have negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Well, I know negative of a negative is positive. Negative 8 times negative 8 is positive 64. Negative 4 times 1 is negative 4. And then times 16 is negative 64. And then 4 times 1 is 4. 64 minus 64 is 0. The square root of 0 is... Anybody? It's 0. And if I have 8 plus 0, what do I get? 8. If I have 8 minus 0, what do I get? 8. So either way, I just get 8. So I have one answer to this. That answer is 2. That's not right. What did I do wrong? I put a 4 here. What number is supposed to be there? It's supposed to be a 2. Mr. Kulik, you are el stupido. I can't believe you didn't yell at me first. You should. You thought I was right. You give me too much credit. I just got done telling you how tired I was. All right. My apologies on that. I just wrote down the wrong number. I don't know why. You ever make a mistake? Happened to me. Okay. So, did you notice anything about this starting problem? I could have factored this, right? So, how to factor this? I need two numbers that multiply to give me negative or positive 16 and add to give me negative 8. It's negative 4 and negative 4. Which one was faster? The factoring was potentially much faster if you're good at it, right? So that's the advantage still. That's why we start with the factoring, is because if you're good at it, it's much, much faster. Now the catch is, it's not always going to work. Let's see an example of that. Yes, Nancy. Of course. So let's say we have 2x squared minus 7x minus 18 equal to 0. Could I factor this? I don't know, maybe. If I am able to factor this, though, I'm going to have to do the long factoring, right? Because the leading coefficient isn't 1. That's probably at least as much time as just using the quadratic formula would be, right? And I'm not even guaranteed that I'm going to be able to factor this if I go down that route. So I'm not even going to bother trying to factor this because I don't think it would be any shorter than it would be to use the quadratic formula because I'd have to do the long factoring here. So if I'm not instructed to use factoring to solve this, I won't use factoring if I have to solve using the long method. You guys know what I mean? Just trying to make our lives easier. What's my values for A, B, and C here? 2, negative 7, negative 18. Everybody agree? Okay. So when I plug into the formula, negative B plus or minus square root B squared minus 4 times A times C all over 2 times A. So, negative of negative 7 is just positive 7. Negative 7 squared is 7 times, or negative 7 times negative 7, which is positive 49. Negative 4 times 2 is negative 8. Negative 8 times negative 18 is a positive 144. And then 2 times 2 is 4. Now 49 plus 144 is 193, is that right? And I don't think I can simplify the 193. I don't think that contains a perfect square factor. I'd have to really, I'm positive it doesn't, but I don't know if it can, what if it's prime or not. It might be prime. It kind of looks like a prime number. Anyways, this would be our final answer. So, to kind of wrap things up, when we talk about solving, we now have 3 techniques. We can factor. The pro for factoring is it's pretty fast when you're good at it. The con is it doesn't work in every case. When it does work, it's usually a good option, but it might not always work. Solving directly. Pro. It's fast in certain cases. What are those certain cases? When we have one kind of x. The con is that it's really long because you have to do the completing the square and all those other situations that aren't where we have one kind of x. And the third method now that we have is the quadratic formula. The pro here is that works in every situation. It always works, and it's really the same amount of work. It doesn't get really any worse other than like the numbers might get a little less convenient, but it's not like it's a new process or becomes a longer process or something. The con here is it's longer than the shortest or quickest, maybe, methods. So you're trading versatility for a little bit of speed, right? If I can factor, and it's an easy factoring, that's going to be faster than using the quadratic formula. But if it's the long factor, the quadratic formula is probably faster. If you can solve it directly where you have just one kind of x, that's probably faster than the quadratic formula. But if you can't, the quadratic formula is going to be much faster than trying to complete the square. So it's like, if there's not a shortcut, we use the quadratic formula as kind of my recommendation. Now, for tomorrow, I've posted an assignment on Power School where I've given you 14 quadratic equations. Some of them have obvious, some of them are obvious what to do with, like they're easy shortcuts to deal with. Like it's obvious to factor this or use solving directly or quadratic formula. Try to pick the best or fastest method for each one. Don't try to do them all the same way. Try to pick and choose the fastest way to do them. Next time we come to class, I need for you to bring your specific graphing calculator. We're going to program something into our graphing calculator that you'll want to have on your graphing calculator going forward. So don't just borrow your friends to bring in, because the program won't be on your calculator come time to use it. It'll be on your friend's calculator, which is not going to be very helpful to you. You want to make sure you have your graphing calculator, because we're going to write a program together to help us do the quadratic formula. Okay. That's it for us.